Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. A homeowner's insurance policy covers losses due to theft with a deductible of 3. Theft losses are uniformly distributed on 0 to 10, on the interval from 0 to 10. Determine the moment-generating function m of t for t not equal to 0 of the claim payment on a theft. And here is the solution. Let us write x for the random loss and y for the claim payment. Since x is distributed uniformly on the interval from 0 to 10, the density of x is equal to 1 over 10 minus 0, which is 1/10 or 0.1, for x between 0 and 10, and the density is 0 otherwise. Also, y is equal to the maximum of 0 and x minus 3. Then so basically y is equal to 0 when x is less than 3, and it's x minus 3 when x is more than 3. Then we have the following. The moment-generating function of y in the problem called m of t. I'm just going to write it as m sub y of t because I like writing the subscript representing the random variable there. So it's m sub y of t. By definition, this is equal to the expected value of e to the ty. Okay, well, for x values between 0 and 3, y is equal to 0, so this is the interval from 0 to 3 of e times 0 times 0.1 dx, plus for x values more than 3, y is equal to x minus 3. And therefore, for x values more than 3, we have the interval from 3 to 10. 10 is the endpoint of the interval where the density is positive. So basically, it represents the area where there are any values of x that can happen, that have positive probability of happening. And then we have e to the power t times y, which is x minus 3 in that interval, times the density of 0.1 dx. And the first part of this integral, well, e to the 0 is 1, so this is the integral from 0 to 3 of 1 times 0.1 dx, and so it's an integral of a constant, and it equals to that constant times the length of the interval. So 3 times 0.1, which is 0.3, plus the integral from 3 to 10 of this e to the t x minus 3 times 0.1 dx. I'm going to call this x minus 3 z, and as x runs from 3 to 10, z runs from 0 to 7. I'm going to put the constant of 0.1 in front, and this becomes 0.1 times the integral from 0 to 7 of e to the tz dz. That's equal to 0.3 plus 0.1 times s bar angle 7 with the force of interest delta equal to t. And therefore, this is equal to 0.3 plus 1/10 times e to the 7t minus 1 over t. That's the s angle 7 at delta equal to t. And that's the same as 3 over 10 plus e to the 7t minus 1 over 10t. And that's answer A. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.